this unit that we're learning isn't about force. What's it about? Energy. So really what we're looking for is not actually the force on the spring, which we can find, right? We want to find out how much energy do we store in this spring. And the way we do that is by actually looking under the area of this curve. So actually, if you want to, just draw a very simple graph of a linear line, please. All right, so if I was to ask you guys, what's the area under that curve? Could you do that for me? You guys do that for me real quick? Yeah, you just do it at that point. That works. What was that? Exactly. It's 1/2 base times height. So what's our base? Yeah. What is it? What units do we have then? It'd be distance. Okay. So if we want to draw that. Yep. And what was our y-axis? The force. So if we want to write E equals 1/2 F times x. So the energy is actually area under this curve, which ends up being 1/2 F times x. Now let's replace this F. What do you guys think we should replace it with? If you're looking up here, what do we have? What do we just establish? Yeah. You'll be back there, right? Just going. Okay. What's the force equal to? What's that? Exactly as he said. The force is equal to the spring constant times the displacement. Does that make sense? So if we replace that if we replace the force in for the spring constant times the displacement, what do we get? We're going to actually do that, and we're going to actually plug that in. So, exactly. Plug that in. Yep. Perfect. This is our new equation, our first equation for energy. I would like you guys to write this into your equation sheet, and you guys can sit. Yeah, actually, you guys can sit. And write in your equation.
The bottom one?
But you want both of these. So this is the force on a spring. So force is spring constant times x. So the more I displace the spring, the more force is on it. And the energy that's in that spring, the energy that I store in this spring, is equal to 1/2 times that spring constant times the displacement squared. All right? This is also known.
Take capital.
Yeah, no, it's actually lowercase. Good question.
So we want the E equals 1/2 Fx and E equals 1/2.
Yeah, so you want this and this. All right? This is also known as Hooke's law. Hooke's law. Robert Hooke, his name was, yes.
What is the base thing for now?
That's the spring constant. All right? Now that's a number that will depend on the actual spring you're working with. Was that?
Would it be a given and then
It might be a given. You might have to solve for it sometimes. All right? But it'll always be the same for the same spring. Okay, this is called Hooke's law. This is the same for springs. This is the same for rubber bands. They all have a specific spring constant. All right, so this is the energy elastic that we're talking about. Remember that? Energy elastic. So like in the one problem, in the first problem, we had that ball hit the ground. A ball can have a spring constant. All right.